height h of an arrow in feet is modeled by this equation where t is the time in seconds since the arrow was shot. How long is the arrow in the air? So it's in the air, it's shooting up, and then it comes back down, and we're wondering when is the height going to be 0 again. So we are going to be subbing in for h of t, we're looking for when that height equals 0. So we'll say 0 equals negative 16t squared plus 63t plus 4. Thank goodness we practiced all that factoring last week. I see my lead coefficient is negative, so we're going to factor out a negative, which makes everything the opposite. We're dividing it all by negative 1. All right, so remember when we have a number in front here as an a, we have to multiply it with the end. 16 times negative 4 is negative 64. We're looking for factors of 64 that are 63 apart, which would be 1 and 64. So that would come in as minus 64 plus 1. But remember the old trick. We have to try to divide them by a, which in our case is 16. So if we clean some stuff up here, we got the negative outside. 64 divided by 16 is 4. And then here we would scooch to the front, make it 16t plus 1. Now remember, each part of this gets its own equation. The negative out in front doesn't even matter. You can divide both sides by negative 1. 0 divided by negative 1 is still 0. So we would just set up t minus 4 equals 0, and 16t plus 1 equals 0. Remember, t is time in seconds. So here we would add the 4. So t equals 4, which makes sense. 4 seconds, that's all good. That would make sense, that it's in the air for 4 seconds. Let's see what happens over here. First we'd subtract the 1. 16t equals negative 1. And then we would divide by 16. So we'd have negative 1/16 seconds. That doesn't really make sense for this. So that would be eliminated as an option. Cool. All right, let's try the other one. A juggler throws a ball in the air from a height of 5 feet with an initial velocity of 16 feet per second. Write a function that can be used to model the height after t seconds after the ball is thrown. How long does the juggler have to catch before it hits the ground? So if we were setting up that h of t function, remember it's always negative 16 times t squared with these. The velocity is 16 feet per second, so that becomes our b. Plus 16t plus our starting height, and it said we were starting from a height of 5 feet. Here's our general formula for this situation. Now we want to know when it's going to be hitting the ground again. When the height equals 0. So that seems to be a common thread for most of these problems. We're going to do the same thing. We're going to factor out our common factors, a negative in this case. Factor out the negative 1. 16t squared minus 16t minus 5. Factoring, we're going to multiply our first and last. 16 times negative 5 is negative 80. So we're looking for factors of 80 that are 16 apart, 20 and 4. So it would have to be minus 20 plus 4. And we have to try to divide them by that a, which in our case is 16. Now, neither one of these can evenly divide by 16, but we can simplify them both. 20/16 would reduce to 5/4. 4/16 is 1/4. All right, so here's what we got. 0 equals, negative. Then you got 4t minus 5. And you have 4t plus 1. Remember, each of these gets its own equation here. So 4t minus 5 equals 0. 4t plus 1 equals 0. We're looking for time. So here we'd add the 5. 4t equals 5. Here we would subtract the 1. 4t equals negative 1. On both of them, we're going to divide by 4.